Good morning, students. Today, we will discuss some more work examples about magnifying glass. There will be 3 questions, which will be discussed in 3 different videos. Now, let's begin with number 1. A person with normal eyes means PP equals to 30 cm and PR equals to infinity is observing an object through a magnifying glass without accommodation. The distance from the object to the lens is 20 cm. Question A. Calculate I. The focal length and the power of the lens. The answer key for this question, the focal length equals to 20 cm and the power of the lens equals to 5 diopters. We will try to solve this question first. From the problem we know that the PP of the person equals to 30 cm. Usually, normal eye has a PP of 25 cm. But because it is stated in the problem 30 cm, so we will use 30 cm instead of 25 cm. The PR of the person equals to infinity. The distance between the object and the lens, SO, equals to 20 cm. In question A, the person is observing without accommodation. If the person is observing without accommodation, it means that the SI, or the distance between the image and the lens, must be equal to negative PR. Negative means it is a virtual image. PR is based on this condition without accommodation. So, it is equal to negative infinity. Now, the question asks us to calculate the focal length and also the power of the lens. This is for question I. To calculate the focal length, we will use the general equation 1 over SO plus 1 over SI equals to 1 over F. The SO is 20 cm. SI equals to negative infinity. So I put negative sign in front of 1 over infinity. This equals to 1 over F. Remember, 1 over infinity equals to 0. So we have 1 over 20 equals to 1 over F. It means that the focal length equals to 20 cm. Now, let's calculate the power of the lens. To calculate the power of the lens, we will use equation 100 over F. The focal length equals to 20 cm. So the power of the lens equals to 5 diopter. These two answers match the answer key. Let's check again. The answer key, focal length equals to 20 cm and the power of the lens equals to 5 diopter. Now let's move on to question II. Question II asks us to calculate the angular magnification and the distance from the image to the lens. Based on the answer key, the angular magnification must be equal to 1.5, and the distance from the image to the lens must be equal to infinity. Let's try to solve this problem. I'd like to remind you that in question A, the person is observing without accommodation. If the person is observing without accommodation, then the SI must be equal to negative PR. The person has normal eyes, so the PR of the person equals to infinity. To answer question II, we get the value of the SI directly from this condition without accommodation. SI is the distance between the image and the lens. So, the answer is SI equals to infinity. The next question in question II is calculating the angular magnification. Remember, there are three equations to calculate angular magnification of a magnifying glass. So we have to choose which equation is suitable or the correct one to calculate the angular magnification for this condition. The condition is without accommodation. So, the correct equation is angular magnification equals to PP over F. The PP of the person is 30 centimeter. The focal length, we get the value of the focal length from the previous problem, which is 20 centimeter. So the angular magnification for the condition of without accommodation equals to 1.5 times. Let's check our answers with the answer key. Angular magnification 1.5, the distance between the image and the lens infinity. The angular magnification 1.5 and the distance between the image and the lens is infinity. So we get the correct answer. Now we will continue with question number B. If the person wishes to observe with maximum accommodation, calculate I, the distance from the image to the lens, I, the distance from the object to the lens, I, the angular magnification. We will try to solve these questions one by one. Now in question B, the person is observing with maximum accommodation. This means that the SI must be equal to negative of PP or negative 30 centimeter. Remember, the negative sign here only shows us that the image is a virtual image. So, to answer question number BI, we don't have to write down the negative sign because the distance does not require the sign. So the distance between the image and the lens or the SI equals to 30 centimeter. Question II asks us the distance from the object to the lens or the SO. To calculate this, use the general equation 1 over SO plus 1 over SI equals to 1 over F. 1 over SO minus 1 over 30 we have to put in the negative sign here, equals to, remember from the previous question, we know that the focal length is 20 centimeter. The condition of accommodation does not change the value of the focal length. 1 over SO equals to 1 over 20 minus negative 1 over 30, which gives us 3 plus 2 over 60. So the SO equals to 60 over 5, which is 12 centimeter. The last question, in triple I, we have to calculate the angular magnification. Since now the person is observing with maximum accommodation, the suitable or the correct equation to calculate the angular magnification becomes PP over F plus 1. The PP is 30 centimeter. The focal length is 20 plus 1. This equals to 2.5 times. Now let's check our answer one by one with the answer key. SI 30 centimeter, SO 12 centimeter, and the angular magnification is 2.5. The distance from the image to the lens is 30, the distance from the object to the lens is 12, and the angular magnification is 2.5. All of them are correct. So now we will move on to question C. If the person wishes to observe with an accommodation at a distance 60 centimeter, calculate I, the distance from the image to the lens, double I, the distance from the object to the lens, and triple I is the angular magnification. Let's try to solve these questions one by one. In question C, the person is now observing with accommodation at a distance 60 centimeter. From the two previous problems, we know that the position of the image must be based on the condition of the accommodation. So, if the accommodation is at a distance 60 centimeter, the image must be placed exactly at a distance 60 centimeter too. So we can write down SI equals to negative 60 centimeter. The negative sign shows this is a virtual image. To answer question CI, we don't have to include the negative sign in the answer. Why? Because, once again, the negative sign only shows the properties of the image, which is virtual. So the distance itself does not require the negative sign. But in the calculation, the negative sign must be included. In question II, we are asked to calculate the distance from the object to the lens. It is called SO. Use the general equation 1 over SO plus 1 over SI equals to 1 over F. 1 over SO minus 1 over 60 equals to 1 over, remember, the value for the focal length, we get it from the question number A. It is 20 centimeter. This gives 1 over SO equals to 1 over 20 plus 1 over 60 equals to 3 plus 1 over 60 or 4 over 60. So the SO equals to 60 over 4, which is 15 centimeter. The last question in C is the angular magnification. Remember that the accommodation is at a distance 60 centimeter. So, the correct equation to calculate the angular magnification for this condition is PP over F plus PP over X. The X here is the 60 centimeter. So we can substitute X with 60 centimeter. PP equals to 30 centimeter. The focal length, once again, we get it from question A, 20 centimeter, plus 30 over 60. The X is 60 centimeter. This equals to 1.5 plus 0.5, which equals to 2 times. This is the angular magnification. This is the distance from the object to the lens. And this is the distance from the image to the lens. Now, let's check our answers one by one with the answer key. The distance from the image to the lens is 60 centimeter, the same as the accommodation distance. The distance from the object to the lens is 15 centimeter, and the angular magnification is 2 times. So all of our answers are correct. And this is the end for our discussion for number 1. We will continue the discussion in the next video.